Here we are, guys, in chapter 5, looking at trigonometric identities. And here in this section, we're going to be focusing on the basic trigonometric identities and mixing that with some algebra. And we're going to be also proving some things with our trigonometric identities. So first of all, an identity is, if something's an identity, it is true for all values of x. Okay? So we should know these already. So the reciprocal identities. Cosecant of x is 1 over sine of x. Secant of x is 1 over cosine of x. Cotangent, 1 over tangent. And with those three, we could also write that sine of x is 1 over cosecant of x. That cosine of x is 1 over secant of x. And that tangent of x is 1 over cotangent of x. So those are just an extension off of the basic three. And then with our quotient identities, we know that tangent is sine over cosine, and that cotangent is cosine over sine. So within this section, we're going to be using these identities to simplify and to prove algebraic expressions. So let's begin. So let's simplify these expressions into a single trig expression. So the very first tip, hot tip number 1, use the identities to rewrite in terms of sine and cosine. So whatever we have, we're going to try to rewrite in terms of sine and cosine. So let's begin. So cotangent, we know cotangent of u is cosine of u over sine of u. Okay. We know that secant is 1 over cosine of u. And then we have sine of u. So as we examine this, cosine in the numerator, cosine in the denominator, they cancel, but really they just divide to 1. And then we have sine in the numerator, sine in the denominator, they cancel, they go to 1. So this whole entire expression with each piece canceling simplifies to just 1. They might argue this is not a trig expression. Well, this is just the identity, it's just 1. Let's try another. Cosecant of alpha times secant of alpha divided by cotangent of alpha. So before I rewrite this in terms of sine and cosine, I'm going to get this fraction out of the way. So I'm going to say cosine of alpha secant of alpha multiplied by 1 over cotangent of alpha. So in doing that, I can now rewrite it again. So cosine of alpha, secant is 1 over cosine. Okay. And then 1 over cotangent, from our reciprocal identities, we know 1 over cotangent is just tangent. So cosines cancel, leaving with this expression simplifying to tangent of alpha. So using sine and cosine, just simplifying it, bringing everything back to those two ratios, or those two functions. Let's try some more. Hot tip number 2. Hot tip number 2. So start with the more complicated side. So with that complicated side, work on transforming it to the other side using our basic identities that we just focused on, algebra, techniques, and other established identities that we're going to build on that throughout this unit, this chapter. So verify the identity. So when we verify an identity, what that means is we know that this is true. If you do not already, this is true. So verifying that it's an identity, we want to show that one side simplifies to the other. So we need to show the steps. Show the steps. So using that hot tip number 1, rewriting it in terms of sine and cosine. In this case, let's try that out. So cosine of x, tangent is sine of x over cosine of x. Okay, so we know it equals sine of x still. We're trying to make it just sine of x. We notice cosine in the numerator, cosine in the denominator, they cancel. So we have sine of x equaling sine of x. Yes, that's exactly what we wanted to show, that the left side simplified to the right side. So this is a pretty simple problem. Let's try something maybe a little more complicated. So secant of beta times cotangent of beta equals cosecant of beta. So say secant. I'm thinking that the left side's a little more complicated than the right. So we're going to try to get this and write it as cosecant of beta. So secant we know is 1 over cosine. Cotangent we know is cosine over sine. Okay. We see that simplifies, so which leaves us with 1 over sine of beta. Okay. You're thinking, we're done. 1 over sine of beta is, in fact, cosecant of beta. You are true, but we will need to, this is not verified yet. We do not see that cosecant of beta equals cosecant of beta. So yes, using our identity, 1 over sine is cosecant of beta. It's cosecant of beta. Okay, so this is all about verifying. Yes, we knew from up here, maybe you saw, oh, we had 1 and we had sine of beta. Yeah, that's good. That's what we wanted. No, we verifying, we show the steps. We show the steps in this whole process. Okay, so more hot tips. So along with the first two, we multiply, factor, combine fractions, split fractions. So this is more of an algebraic tool to help us here. So when we combine fractions, so we have x over z plus y over, I don't know, q. We need a common denominator. So to combine the fractions, common denominator, we're going to rewrite this as x times q, and then y we would multiply by z, and multiply the two denominators. So common denominator when combining fractions. When we split fractions, let's take for instance, I had x plus y divided by z. So when we split fractions, we're saying that this expression can be rewritten as x over z plus y over z. So we're going to use these techniques to help us in verifying or simplifying. So hot tip number 4, keep the other side in mind. Simply, whenever you're going through this whole process, sometimes it is not clear what steps you're going to take, but you want to keep your end goal in mind. You want to understand where it is that you want to end with your verification process, or your proving process. All right, so I hope you're writing these tips down. These tips are hot tips. These tips are going to be what carry us through this whole entire chapter. So let's look at the next example. So verify the identity. So we have 1 plus sine of theta over cosine of theta, and we want to show that it is secant of theta plus tangent of theta. So let's try this one out. So there are multiple ways of getting this done, but like maybe I could rewrite secant as 1 over cosine, and this is sine over cosine. Common denominator would help us there. That could work. But I'm going to show you what can be done with this fraction. So I'm going to split this fraction. So I'm going to say this, this is 1 over cosine of theta, and then plus sine theta over cosine theta. So we split the fraction. And then our goal is to end up with secant and tangent. So 1 over cosine of theta is secant of theta, using the identity, and sine of theta over cosine of theta is tangent of theta, and we got it. We have it verified. So I want to encourage you now, verify this one. So this is for you to do. 1 over sine of x divided by 1 over cosine of x equals cotangent of x. So pause the video here and take a try at it. Okay, so in beginning this, the approach that we should have taken here is knowing that 1 over cosine is, yes, it's secant, 1 over sine is cosecant, but when we divide by a fraction, we want to multiply by its reciprocal. So 1 over sine, I was dividing by this fraction, so I multiplied by the reciprocal of that fraction. And I did that because cotangent, I remember, is cosine over sine. So I already kind of had the over sine portion. I needed to get cosine in the numerator. So using the reciprocal there does that for me, and we verified it. All right, so how'd you do? So let's try a couple more at this. All about practice, all about examples. So let's prove this identity. So we have sine of theta multiplied this group 1 plus secant of theta, and we want it to show that it equals sine of theta plus tangent of theta. So we could maybe approach both sides here one at a time. I could do 2 approaches in this video, but I'm thinking I'm liking the look of liking the look of this right side. Yes. Again, you could tackle the left side if you want to. So we're trying to show that the right side simplifies to this. Okay. So sine of theta. Okay. Tangent of theta is sine of theta over cosine of theta. Now watch this. So sine of theta plus sine of theta times 1 over cosine of theta. Maybe you can tell where I'm going here. Okay, so there's a common sign. I'm going to take sine of theta. So that's a 1. And then just 1 over cosine theta, which is sine of theta times 1 plus secant of theta. And there we go. There is a way of doing this using this left side and manipulating it by distributing the sine of theta into this. Sine of theta multiplied by secant of theta will just end up becoming tangent of theta. Okay. So on your own, try this one. Verify cotangent of alpha plus 1 equals cosecant of alpha multiplied by the group of cosecant of alpha plus sine of alpha. So I would recommend maybe working with this right side, but pause the video and take a try. Okay, so how'd you do? Looking at the steps here, we distributed, we rewrote cosecant as 1 over sine of alpha, and then we had some canceling and some simplifying, and we see that it is in fact verified. So much of this whole process of verifying and proving is keeping your end goal in mind, kind of planning ahead what you foresee happening, and just tackling and trying it out. The worst thing that can happen is you have to erase it and try something else. So let's end this video with some algebra review. It's like, Mr. Beal, why are we reviewing algebra here? Well, I mean, if our algebra skills are not the greatest, our skills here are going to be lacking. So let's just review a couple of things. For example, multiplying. 2x, multiply this group. Oh, well, we distribute. That would be 6x squared plus 8x. Awesome. Which would mean that if I'm looking at this expression with trig, I would distribute. That would be tangent of x, cosecant of x, minus tangent of x, which simplifies to sine of x over cosine of x. And then that would be cosecant of x is 1 over sine of x. And then we have some canceling, which is 1 over cosine of x, which becomes secant of x minus tangent of x. So I'm going to put some arrows here to designate the different rows or different steps. And our final step. So as we can see, this algebra process with trig has a little more into it, but it's not bad. Just knowing our identities and working with it. So multiplying, let's see, we would have 6x squared plus 8x minus 15x, and then minus 20, which becomes 6x squared minus 7x minus 20. Okay, whether you use a box there, whether you use other methods, we know how to multiply two binomials. So what if we want to multiply two things that have trig functions within it? So we just still use the same concept. Sine times sine is sine squared. So sine squared, just so you know, I could use parentheses, sine of x and squared, or we could write sine of x, or sine squared of x. Okay, not sine of x squared. I think we talked about this before. Putting the squared after the x signifies that we're squaring x and not the actual sine function. Okay, then we want plus sine of x cosine of x. I'm writing a little smaller because I'm going to run out of room. And then minus cosine of x sine of x. And then minus cosine squared of x. Okay, well, positive sine cosine, negative cosine sine, they cancel. And then, which leaves us with sine squared of x minus cosine squared of x. So, let's try some algebra fun with factoring. So this is where we look for a common term. We've already done this already in this lesson. So 12x squared minus 21x, we know that there's a common x that's going to be pulled out, but also we can factor out of 3, which has 12 becoming 4x, and 21 would become minus 7. All right, and then x squared minus 2x minus 35. Oh, okay, I could use my whole little snowman or box or checkerboard, whatever you want to call it. But this is going to become x minus 7 quantity multiplied by quantity x plus 5. Okay, so let's try this with trig. Sine squared of x minus sine of x. So we notice we have two sines here and one here, so we can pull one sine of x out, leaving us with a single sine of x and minus 1. And then on our last one. So this looks a little nasty, but what if we saw this as x squared minus 4x minus 32, factored this, and rather than writing just x like we would have up top here, we would just write in sine. Okay, so if I factor this, I'm going to have, it would be x minus 8 and I believe x plus 4. But substituting sine back in, sine of x minus 8, sine of x plus 4. All right, so these techniques, factoring and multiplying, these are going to be techniques that we will need for the remaining topics in this chapter. Because this chapter is going to be really using identities to verifying, in order to verify expressions, to prove things, to simplify things. So having these techniques down will make this process easier. Okay, so I wish you the best of luck in the practicing, simplifying, and verifying, and I'll see you in the next video.